Welcome to the deep dive.
Great to be here.
So, based on the sources you shared, developer blogs, tutorials, some really interesting motivational stuff too, we're diving into game development today.
Yeah, specifically tackling that big myth. Right.
Exactly. The mission is proving, using what these sources say, that getting started is way, way easier than people think.
It's this idea you need to be some kind of, I don't know, coding genius or spend years just learning.
Right. That's the wall we're trying to break down.
And the sources are pretty clear. The truth is you really can't start making something like today.
Even with zero coding background.
Even with absolutely nothing beforehand. That's the core message.
I think, people see these huge, complex, modern games.
Yeah.
Maybe an open world thing.
Yeah.
And it just looks impossible.
Totally understandable. They seem like mountains to climb.
But the insight from the sources is that the basic building blocks, they're actually the same.
Fundamentally, yes. The DNA of a massive AAA game isn't that different from the simplest possible game, structurally speaking.
It's about isolating those core ideas.
Exactly. Master the absolute basics in a tiny project, and you suddenly have the language to understand much bigger problems.
Okay, so let's unpack that. If we can start today, where should we aim? Not for the blockbuster, obviously.
Definitely not. Aim for immediate success. Quick validation.
And the sources all point towards games with just one single, simple mechanic.
Yeah. Keep it incredibly focused. They give a few key examples.
What were they? A simple runner game.
Right, like an endless runner. Or a Flappy Bird type game, tap to fly.
Okay, tap game. And a basic 2D platformer, like just jump.
The absolute simplest version, yeah. Just moving and jumping.
And the interesting part isn't just that they're simple.
No, it's the why. Why these specific types?
It's because they're basically teaching tools, aren't they?
Precisely. They isolate fundamental game concepts without overwhelming you. You're not worrying about story or complex art yet.
Just the absolute core loop.
Input, consequence, state change. That's it. Learn that first. Player input, collision detection. They nail those basics.
Okay, let's dig into those building blocks more. The Flappy Bird example seems almost trivial on the surface. Just tapping.
It seems trivial, but mechanically, it's fascinatingly simple and effective.
How so?
You've basically got just two forces acting on the bird, right?
Okay.
There's the player's tap, which gives it a little upward push,
Mm-hmm.
an impulse.
And then gravity just pulls it down constantly.
Exactly. Constant, predictable gravity. That interaction is the game.
But the sources say we learn more than just up and down from that simple loop.
Oh, definitely. By the time you've cloned a basic Flappy Bird, you've had to figure out several key things.
Like what?
1, how to translate player input into movement. Simple movement, but still.
Okay, input to movement.
2, collision detection. Did the bird hit a pipe or the ground? That's crucial.
Right, the fail state.
3, scoring. How do you even track passing the pipes? You need some logic for that.
And 4.
Just managing the game state, being in playing mode versus the game over screen, switching between them.
Movement, collision, scoring, state management, that's actually quite a lot from just tapping.
It's the bare minimum for something to feel like a game, really.
Okay, what about the simple runner then? Player moves forward, automatically you just jump over stuff.
That one teaches a slightly different set. The sources highlight physics and timing.
How does the auto run help?
Well, straight away, you're dealing with level progression. Even if it's simple, stuff needs to appear ahead of the player.
So spawning obstacles.
Exactly. Spawning things at the right time, making it feel continuous. And the jump, that forces you into basic physics.
Like how high you jump, how long you're in the air.
Yeah, acceleration, gravity's pull, maybe even a little deceleration. It's all tied to player reaction. Timing becomes key.
And the sources mentioned animation too.
Right. Even super simple animations, like a little run cycle or a jump pose. It teaches how the code logic connects to the visual feedback.
The code says jump, the animation shows jumping.
Exactly. And connecting this back, these skills,
Yeah.
timing, physics, collisions, spawning.
They're not just for beginners.
Not at all. They're fundamental algorithms. Pros use these same concepts, just scaled up, massively scaled up
Yeah.
sometimes.
So making a Flappy Bird isn't just making a Flappy Bird, it's learning the language of game logic in its simplest form.
You got it. Using the simplest vocabulary to speak the complete language.
Okay, so if the goal is that quick win, that validation,
Yeah.
we need the right tool. The sources really hammer on Unity.
Yeah, Unity comes up a lot.
But game engines can look terrifyingly complex when you first open them. Is Unity really that beginner-friendly?
It can be, yes. The key thing the sources point out is its component system.
Component system, like building blocks.
Sort of like digital Legos, yeah. Instead of writing physics code from scratch, calculating gravity, forces, all that math,
You just grab a physics block?
pretty much you grab a component called, say, a rigid body, you attach it to your player object, boom, it now has physics, gravity works, forces can be applied.
You didn't write the physics engine itself.
Nope. Unity provides it. Same for collisions, you add a collider component. It handles the math of figuring out if things are touching.
Ah, so that's how they get to that number. The sources say you can get something working, something playable, with just 5 to 10 lines of code.
It sounds unbelievable, but it's because those 5 or 10 lines aren't building the complex system.
They're just telling the components what to do.
Exactly. Your code might just say, hey, rigid body component, when the spacebar is pressed, add a bit of upward force. That's your jump.
You're writing the instructions, not the engine.
Precisely. You're leveraging all this pre-built power.
And that moment, you write those few lines, press play, and your little cube or sprite actually jumps. The sources call it pure magic.
It really feels like it because you went from nothing, just an empty screen, to an interactive thing that you made.
That's the hook, isn't it? The
Yeah.
immediate feedback, the proof you can do it.
It's incredibly motivating. It validates the effort immediately and shifts your mindset. You realize, wow, I actually built a working piece of software.
Okay, so that first success is key. But
Yeah.
what then? You finish the tutorial, your little bird flaps, your runner jumps. How do you go from just copying steps to actually, like, creating something new?
That's a really important question. The sources suggest the transition comes from curiosity, basically.
Yeah.
And managing scope.
Curiosity how?
Once you have that working base, that controlled little game,
Ah.
the learning starts when you ask, what if?
Like deviating from the tutorial.
Exactly. You finished the runner tutorial. It works. Now you think, okay, what if I tried adding a power-up that makes you jump higher for a bit?
Or what if the obstacles move sideways too?
Right. Or what if I change the gravity? You start poking at it, introducing small changes, small elements of risk.
So you move from can I follow instructions
Yeah.
to what happens if I try this?
That's the shift. That's when you start becoming a creator, defining your own little problems to solve within that simple framework.
And you mentioned scope management.
Oh, absolutely critical. This is where beginners often stumble. They finish Flappy Bird and immediately try to build, I don't know, a giant RPG.
Right, the ambition suddenly explodes.
And it leads to burnout. The successful path, according to the sources, is iterative, micro goals.
So instead of build an RPG, it's add a double jump to my runner.
Exactly. That's one small, achievable project. Then maybe add background music that speeds up. Another small project. Keep the wins coming quickly.
It's like building a staircase of skills, one small step at a time.
Perfectly put. Each small success builds confidence and prepares you for the next slightly harder thing.
And just to really hammer it home, let's recap what the sources say you don't need. Because that myth is persistent.
Right. You do not need some super-powered, expensive computer. A basic laptop is fine for these sims games.
You don't need years of programming experience beforehand.
Absolutely not. You learn the tiny bits of code you need as you build the simple game.
Yet you definitely don't need to wait for some grand moment of inspiration, the perfect idea.
No. Just start. Make anything. That simple runner, that tap game you build today with maybe 10 lines of code, that's the first step. It could unlock a huge new area for you.
So wrapping this deep dive up, the main takeaway seems pretty clear. That big, scary barrier of complexity, mostly an illusion at the start.
It really is. Focus on those ultra-simple mechanics. The runner, the Flappy Bird style. They teach you real professional-level concepts, but in a manageable way.
Using things like Unity's components, like the rigid body, lets you control complex systems without writing them from scratch.
And it all starts with that first taste of success. Making something move, making something react. That spark fuels everything else. One simple idea actually executed.
Every single pro developer, even the ones making games that blow your mind, they started somewhere simple too, right?
Absolutely. Nobody starts by writing a million lines of code. They start with one character, one jump, one collision. That one moment they realize, I can control this digital world.
So, thinking about you, the listener, what does this all mean? Well, the skills you get from breaking down Flappy Bird are the same skills you can use to understand much bigger games.
It's directly transferable knowledge. Analysis is key.
So here's a final thought, building on that. Think about a complex game mechanic you really admire. Maybe it's destructible environments in a shooter or a complex crafting system.
Something that seems really intricate.
Yeah.
Huh.
Could you, right now, try to break that down using that component thinking? What might be the 4 or 5 simple individual steps or rules that make that complex system work?
Just analyzing it, breaking complexity down into simple parts, that's the first step towards eventually creating complexity yourself, a really powerful exercise.